that solve the following system of linear inequality. We'll begin by considering the linear inequation 3x minus 1 is greater than or equals to 5. We'll transpose 1 to the right hand side to get 3x is greater than or equals to 1 plus 5. So we have 3x greater than or equals to 6. Now we want to make the coefficient of x 1. To do that, we'll have to divide both sides with 3. But before doing that, let me state the property of the linear inequality. It states that if we have two numbers a and b such that a is greater than or equals to b, and we also have another number c which is a positive number, then if we divide a with the positive number c and b with the positive number c, then a over c is going to be greater than or equals to b over c. That means the sign of the inequality is not going to change. So that means we'll divide both sides with 3, and this is not going to affect the sign of the inequality. So we'll have x greater than or equals to 2. Let's label this as number 1. Coming to the second linear inequality, we have x plus 2, which is greater than negative 1. So here we have x greater than negative 2 minus 1, or x greater than negative 3. So let's label this as number 2. Now what we'll have to do, we'll have to find a solution that is common to both 1 and 2. For that, we are going to sketch a number line. On it, we'll have x equals to negative 3 and x equals to 2. Now, the first one says that x is greater than or equals to 2. So that means we'll consider on the number line all the values of x which lies to the right of x equals to 2, and 2 is also included. So that's why I've used a dot here, and it's going to extend all the way up to positive infinity. So this is the solution to number 1. And for number 2, we have to consider all the values of x which is greater than negative 3. So here negative 3 is not included, so we'll use a bubble here, and this will consider all the values lying to the right of x equals to negative 3 and extending up to positive infinity. Now we'll have to find a solution that is common to both of them. This is the region which is common to both of them, and this will be a solution set. So if we write them in the interval form, we have a solution going from 2 to infinity. So by definition, infinity is unbounded, so we'll have to use an open interval, whereas x equals to 2 is a part of the solution, so we'll use a closed interval. So this is a solution to a given system of linear inequality.